Okay, now if you had noticed in the two expressions that we just derived, the one for conduction band involves EF and EC, and the one for valence band involves EF and EV. So if you want to find out the number of electrons or the number of holes, it seems that you need to know where the valence band ends or where the conduction band starts. So is there a way to eliminate those terms? So that's what we're going to see. We're going to try to bring things in terms of EF, or to give a more formal definition of EF, the Fermi level. Now before we go into that, like we already discussed, N is equal to P, or the number of electrons in the conduction band should be ideally equal to the number of holes in the valence band, because every time an electron moves, a hole is created. So these are the two expressions we derived. NC, this is for the conduction band, this is for the valence band. We equate both. So, and then you take NV by NC on one side and the e to the power terms on the other side. E to the power E minus EC minus EF upon KT by e to the power minus EF upon EV by KT is equal to NV by NC. Now for this, again we have this expansion, right? This thing which we just saw here, just a second. So yeah, these are the expressions we saw for the conduction band and the valence band respectively. Now we are going to take NV and NC to one side and the E raised to terms to one side. You will get this. And now we need to remember that NV and NC are constants which we substituted. For example, we had a whole bunch of constants here which we combined to call NV. Similarly, in the previous derivation, we had another bunch of constants there. That is what we called NC. So this left hand side is the same over here. Here instead of NV by NC, we are putting back whatever constants we had there. And then you club everything on the LHS into one side. On the RHS, you cancel whatever gets cancelled. Finally, this is the expression you will get. E to the power 2EF minus EC minus EV upon KT equals MH star upon ME star whole raised to 3 by 2. This is the expression we get. Now, because we have an e to the power here, so first, what is our objective in doing all this? We are trying to create a formal expression for EF. So in order to bring this part into the picture, to remove the e, we take logarithm on both sides. So you get this expression. So finally, so 2EF minus EC minus EV upon KT equals 3 by 2 ln MH star by ME star. Now you keep EF alone on the other side and send everything else to the RHS. This is the final expression you get. EF is EC plus EV by 2 plus 3 KT by 4 ln MH star upon ME star. So what did we just do here? We equated the number of electrons with the number of holes. We took all the e power terms on one side and the NV NC terms on the other side. NV and NC we replaced with the actual constants. We cancelled whatever could be cancelled, and then when there was an e power term, we took a logarithm, and we just kept EF on the left side and sent everything else to the right side as appropriate. This is the expression we got. So for any given values of EC, EV and a particular temperature, if you want to find out EF, this is the expression. And one important insight which we need to draw from this expression is, at 0 degree Kelvin, your T is equal to 0. So this entire part becomes 0. And then your EF is equal to EC plus EV by 2. So what does this tell us? At 0 Kelvin, my Fermi level is going to be exactly the mid level between my conduction band and valence band. So if my valence band ends here and my conduction band begins here, at 0 degree Kelvin, their midpoint would be my Fermi level at 0 Kelvin. So that is an important insight we need to draw. And there is one more important insight, or rather another way of expressing EF, which is Eg by 2 plus 3 KT by 4 ln MH star by ME star, where Eg is energy gap, which is EC minus EV. Now when people look at this expression for the first time, they sort of get confused, because everything else is the same. I have replaced EC plus EV with EG, but I am telling you EG is equal to EC minus EV. So people will be like, how can EC plus EV be equal to EC minus EV? So that's a question a lot of people have, and the answer is this is applicable only with respect to the top of the valence band. So I'll explain. Now what we just saw is that under normal 0 degree temperature conditions, EF is going to be the midpoint, right? EC plus EV by 2, and that will be the midpoint. Now assume the same 0 degree temperature. EG is going to be EC minus EV, which is this gap. So EG by 2 will also be exactly half of this gap, right? So from the start of the valence band, that is from this point to the midpoint, that would be EG by 2. So that would be EC minus EV by 2. So that is exactly what we are meaning when we use this formula. So when I say EG by 2, it is EG by 2 from the start of the valence band. It is like, how do I say? So let's say you are trying to tell your friend an address, for example. There are two ways you can say. You can actually tell them it is the 5th building on the street, or you can talk in terms of absolute location. You can say it is house number 5, or you can talk relatively. It is the 2nd building from the temple. So there's no sense in the question, how can the 5th building be the 2nd building, right? In terms of absolute number of buildings, it is the 5th house, but from a landmark such as the temple, relative to that, it is the 2nd building. So similarly, generally EF is the midpoint of EC and EV, so it is EC plus EV by 2, and under 0 Kelvin conditions. But when I am talking with respect to EV, how far is it from the top of the valence band, it becomes EG by 2, where EG is EC minus EV, the gap between them.